So let us move on to the engine cycle. So basically we are discussing here about a 4-stroke SI engine, and in order to complete this particular cycle we know that it has to complete 4 processes, uh, and the 4 processes are the suction, compression, expansion and exhaust. Now before explaining the working of the 4-stroke engine, so let us discuss to some extent what are the different parts coming into picture. So here you can see this is a intake valve and this is the exhaust valve. So the intake valve is located in the inlet manifold, and the inlet manifold is the passage through which the mixture or the charge is coming into the cylinder, and this is the exhaust manifold through which the burned gases are supposed to go out. And here we have a valve. So when this valve is open, it is expected that the intake is coming in, and when this valve is open, that is exhaust valve is open, the burnt mixture is supposed to go out. And here is the spark plug which when glows, the ignition happens for burning of the charge inside the combustion chamber. So let us start the first stroke. That is, initially we are assuming that the piston is a TDC and the intake valve is open. So now as the piston moves down from TDC to BDC, the pressure inside the cylinder goes on decreasing. That is, we are creating a vacuum inside the combustion chamber, and outside we have atmospheric pressure. So the inside pressure is lesser than the outside pressure, and therefore the air moves through the intake manifold into the combustion chamber, and this process is what we call as suction. So in a SI engine, uh, the mixture is actually the air fuel mixture is moving into the combustion chamber during the suction stroke, and during this particular process the piston is moving from TDC to BDC, and at the end of the suction stroke the piston reaches its bottom dead position. Now second uh, as the second process starts, the piston is supposed to move from now BDC to TDC. Now we can see both the valves are closed, and whatever the mixture has come into the cylinder is getting trapped over here, and the piston is now started moving from BDC to TDC. So as the piston is moving up, the pressure inside the combustion chamber slowly goes on increasing as the piston moves from BDC to TDC, uh, and it goes on increasing till finally the pressure will be maximum when the piston reaches TDC. So theoretically we assume that when the piston is at TDC, the spark is given. So as the spark is given, the mixture starts burning, and the burnt mixture now uh, applies the pressure on the top position part of the piston, that is the piston crown, and pushes the piston towards down. That is, it starts moving from piston starts moving from top dead center to bottom dead center, corresponding to which we call it as expansion stroke or working stroke. So during this particular stroke the piston moves from top dead center to bottom dead center, and as it moves the pressure comes down in the combustion chamber, and finally the piston reaches the bottom dead center. In the next stroke the piston is moving from BDC to TDC. So during this particular stroke you can see the exhaust valve is kept open, and the piston starts moving from BDC to TDC. So slowly the burnt gases are pushed out and until the piston reaches TDC, when almost all the gases, but some gases are still remaining in the clearance volume. So during this particular exhaust stroke, it is expected that the uh, the combustion chamber is flushed out of the exhaust gases. So in all, we have 4 strokes, that is intake stroke or the suction stroke, we have a compression stroke, then we have the expansion stroke, and we have the exhaust stroke. So uh, uh, theoretically, this particular 4 processes are supposed to happen during the completion of one cycle in case of a 4-stroke SI engine. Now let us see the PV diagram, the pressure volume diagram of a 4-stroke SI engine. So correspondingly here on this line axis we are denoting the pressure, and here we have volume. So the as we have seen that discussed in the earlier slide, that during the suction stroke the piston is at TDC. So assuming that this is your cylinder and we have a piston arrangement over here, and this is the position corresponding to when the piston is at TDC, and this is the position corresponding to when the piston is at BDC, and as it moves from here to here we are moving it from, that is swept volume. So and this volume corresponds to clearance volume. Now initially the piston is at TDC and the inlet valve is open, and therefore we assume that as this piston moves from TDC to BDC, the volume inside the combustion chamber is increasing, but since the valve is open, there is no pressure rise happening inside the combustion chamber, so the pressure remains same from 0 to 1, that is during suction stroke the piston moves from TDC to BDC, that is 0 to 1, but pressure remains constant. Now the piston reaches BDC at point 1. Now at the point 1 the inlet valve is closed, and now the charge is getting trapped inside the combustion chamber, and now piston starts moving from BDC to TDC. So as the piston moves from 1 to 2, that is as the piston moves from BDC to TDC, the volume inside the combustion chamber is decreasing. So as it is decreasing, but since the pressure is pressure inside the combustion chamber is increasing due to decrease in volume, you can see this line moving up from point 1, it is moving up until the piston reaches TDC. So this 2 corresponds to the maximum pressure due to compression inside the combustion chamber when the piston reaches TDC. Theoretically, we expect that spark is happening at point 2, that is when the piston is at TDC, and the combustion in a SI engine is assumed to be happening instantaneously. So since the combustion is happening instantaneously, we assume that the piston is not moving, and instantaneously the combustion happens. So when the combustion happens, heat is added, and due to this heat addition, the pressure increases. So the pressure increases during the combustion process. The pressure increases from point 2 to 3, and at the end of the combustion, the pressure reaches to point 3, which corresponds to the peak pressure in the combustion chamber. But this particular 2-3 process is instantaneous, and therefore there is no change in volume. So finally, still at point 3 we have our piston at TDC. Now as the piston starts moving from TDC to BDC, you can see the volume is increasing, and as the volume increases the pressure comes down. So slowly as it moves, you can see the pressure is going on decreasing, and finally at point D, which corresponds to piston reaching BDC. Now at point 4 the piston is at BDC, and we assume that one imaginary process of heat rejection, that is constant volume heat rejection, is added in the cycle in order to make this particular open cycle a closed cycle. So and it is assumed that this process is also happening instantaneously, and therefore the line 4-1 is also vertical. Now this becomes a closed cycle. So in actual, though an IC engine is open cycle, here by adding this particular imaginary process 4-1, we are making this open cycle a closed cycle. Now we assume that now still at point 1 our piston is at BDC. Now piston starts moving from BDC to TDC, that is its 4th stroke. So in the fourth stroke, as the piston moves from BDC to TDC, the volume is going on decreasing, but your exhaust valve is open. So since the exhaust valve is open, at a constant pressure, the the gas inside the combustion chambers are pushed out, and finally it reaches TDC. So the four strokes in the four strokes, so in the is completed now. So the first stroke was the suction, second was the compression, the third was the expansion, and the fourth was your exhaust. And here this heat addition is due to combustion, and this is the imaginary process we have added to make the open cycle into a closed cycle. Why this has been done? In order to make the cycle amenable for analysis, because we know that thermodynamically open cycle are difficult to analysis. So in order to make it easily analyzable, we have added this particular process for one imaginary process to make an open cycle a closed cycle, so that it will be easy for us to analyze thermodynamically. So in all, this is your theoretical PV diagram for four-stroke SI engine. So you can see over here 0 to 1 is your suction, that is 0 to 1 is your suction, then 1 to 2 is isentropic compression, 2 to 3 is constant volume heat addition, 3 to 4 is your isentropic expansion, 4 to 1 is imaginary constant volume heat rejection process, and 4 to 1 that 1 to 0 is your exhaust process. So in all, this is how a four-stroke SI engine works.